All right, guys, today we're going to talk about telomeres. And telomeres are pretty interesting because telomeres are actually related to our aging in our DNA. So one characteristic that it has is actually that every time we replicate our DNAs, because telomeres are the very end of our chromosomes over here, every round of DNA replication is actually being shortened. Okay? So today we're going to talk about telomeres and telomerase. So whenever we're talking about telomere replication, we can think about two different things, or we can look at two different things. So leading strand and lagging strand. So the top strand over here, this one, is a leading strand. And leading strand, since we know that we will always synthesize DNA in 5' to 3' direction, so the top strand will actually, the polymerase will just be able to constantly make and synthesize DNA bases without stopping. But for lagging strand, we have to have a primer once in a while because we're going in the opposite direction. And the problem here is that after we replicate all our DNA information, we have to remove our RNA primer. Okay. And then we're going to fill in with DNA polymerase 3, which adds new bases. Okay. And then ligase and so on. But at the very end of our DNA strand, we cannot add anything to the very end over here. And that is because since we know that we will be needing a 3' hydroxyl, free hydroxyl group over here, but we don't have anything. So what I'm saying is we actually need something over here, okay, that provides a 3' free hydroxyl group so that we can elongate this way. But since that's the tip of the DNA strand, so we actually won't be able to synthesize 5' to 3' direction in that way. So this problem is called end replication problem. And telomerase is the enzyme that actually helps us solve this issue. So what telomerase does is that telomerase is a really useful enzyme that has a RNA primer inside of it. Okay? And this telomerase recognizes the very tip of the enzyme, and then it gets attached to this enzyme over here. The one that's overhanging, this long end, the long stretch DNA strand is called overhang. And this strand attaches to that strand and actually provides a RNA primer so that we can actually elongate the longer strand even longer. So RNA primer is actually over here. So we can elongate this longer strand even longer. Okay? And this long stretch of overhanging end is called, it has a lot of G-rich bases. So that's another thing that you guys have to understand and remember. So after we do this, okay, what we really care about is from here to here, or continuous DNA strand, but up to here. So we only need to copy that much DNA. So this extra DNA that telomerase is providing is actually, it doesn't have any information, so we can just ignore the significance of it. So after we provide base repeats for the overhanging the DNA strand, then we're gonna put a primer here. Okay, and then we'll be able to synthesize and copy the complete DNA strand of the newly synthesized DNA strand. Okay, so there are three things that you guys have to know. First of all, what telomeres are, and then second of all, where to look at, leading strand and lagging strand, of course, those type of stuff, along with the telomerase, and then the third, G-rich bases. So what you guys have to understand is the function of telomerase is that telomerase has an innate RNA primer. It provides it elongates the overhanging end of the DNA so that we could put on an extra primer so that we could completely copy the original DNA replication.